It's funny. Placing numbers in scientific notation. Yay! Click the subscribe button.
Cool. Hey people, how are you? Today, we're going to look at how to place numbers in scientific notation.
What is scientific notation?
It is a way of writing very large numbers or very small numbers. For example, a feather on this animal weighs 0.000000051 tons. How can we write this very small number in scientific notation? Let's get started. There are two parts to writing a number in scientific notation.
What are they?
The first part, or factor, has to be a number greater than or equal to 1 and less than 10.
Like 2 or 7, but not 11?
Yep, you got it. The second part, or factor, has to be a power of 10.
How do we find the power?
I'll show you. So let's take this number. We first need to figure out how to convert it into a number that's greater than or equal to 1, but less than 10. Where can we move the decimal to make it a number greater than 1, but less than 10?
After the 5.
Well, why not after the 1?
That will be 51. And that's bigger than 10.
Exactly. So we need to move the decimal between the 5 and the 1. So let's do that. And count. 1, 2, 3, 4, 5, 6, 7, 8.
8 spaces.
So our first factor is going to be 5.1, a number greater than or equal to 1, but less than 10. Now for our second factor, which is a power of 10, and we find that by counting the amount of spaces we had to move.
8 spaces.
Yes, but which direction did we move?
To the right.
So our exponent is going to be negative. Negative 8. So 5.1 times 10 to the negative 8.
Can you explain?
Well, let's look at our original number. Is this a very big or a very small number?
Very small.
Right. So if we said the exponent was positive 8, that means we're multiplying 5.1 times 10 to the 8th power. That would make the number 510 million. Is that our original number?
Nope.
Exactly. Scientific notation makes it easier to write the number, but without changing the value. Each move to the right, we're dividing by a power of 10. So the number is becoming smaller. I want to look at another example of scientific notation, this time using a large number. So let's take 92,000. Actually, 92 million? Let's add another 3 zeros. 92 billion. This is a very large number. Remember, the first factor has to be a number greater than or equal to 1, and the second factor has to be a power of 10. So we have to think, where can I move this decimal to make this large number a number between 1 and 10? Well, because this is a whole number, the decimal's really at the end of the number. 0.0. So let's move it all the way until we get where? Where can we place this decimal so it's a number between 1 and 10? Well, between the 9 and the 2. 9.2 is definitely a number between 1 and 10. So let's go ahead and take this decimal at the end of the number and move it until we get between 9 and 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our first factor is 9.2. Now, our power of 10 is determined by how many spaces we had to move to get there. And that was 10 spaces. So our power is 10. So our number, 92 billion, written in scientific notation, is 9.2 times 10 to the 10th power. That was fun. So a recap, when writing numbers or placing them in scientific notation, first we have to figure out where to put the decimal to make it a number between 1 and 10, and then we count how many spaces it took, and that's our exponent. If the number we're converting to scientific notation is less than 1, then our exponent is going to be negative. If the number we're converting is greater than 1, then our exponent is going to be positive. Thanks for joining.
See you next time. Don't forget to level up.